Good afternoon, Eniola, Onyi, and Chinoye. Good afternoon. Happy Sunday.
Good afternoon, sir. Good afternoon, sir. Please let's give others maybe 5 minutes to join in before we start today. Good afternoon, everyone. I just sent to the group the data sets that we would use in this session. Please let's download it. Thank you.
Thank you, Chinoye.
Thank you.
Sorry, Chinoye, is it possible to have it here on the chat? I can't see it on my.
Wait, I can try putting it here on Zoom chat as well.
Thank you.
No, please put it on the WhatsApp chat, please.
Have we seen it? It's on the WhatsApp chat.
Okay, I've seen it. Thank you, Naya. I've seen it. I've seen that.
Okay, I think we can get right into it. So I'll be taking the session today. And let's quickly go into what we have for today. So the objectives will be to revise what we did last week, and then I still want to show us a couple more visualizations on Power BI that we could use, and we will talk about data modeling on Power BI, just the entry stuff. So I'm going to start sharing my screen and we'll get right into it. Can we see my screen?
Yes.
All right, thank you. So this is just the welcome page. I have my Power BI on, and on this you can see like different things going on. In the middle you have tutorials, videos that you can watch to understand Power BI, or beginner's knowledge of what Power BI is, uploading your reports, building reports, and getting started with Power BI. Then that's my right, you have what's new, you have forums, you have Power BI blogs, and you also have tutorials by the side. On your left, you have get data, your recent sources. You also have files that you have opened previously. So I'm going to use the file with the Excel sheet we used last week on Kevin's chocolate. I'll bring that in. So if you have your Power BI open, you can just get the data in. So Kevin's Cookies Company is not chocolates. So it's Kevin's Cookies. So while that is loading, we can replicate this on our own laptops as well. So of course it will be financials that we will pick. And if we go through it, we're going to transform the data so that we can delete those columns that we don't really need. Okay, I have to share this screen. So like we did last week, we'll just delete the columns we don't need, like revenue per cookie. You can hold down the control to select multiple columns and right click, remove the selected columns. Let's see. We can check any other ones that we can. Oh, I guess that's about it. Then we close and apply. And it's loading. I'm sorry it's taking so long to load. So essentially what I just want to show us are like various visualizations. So we have like the KPI visualizations, right? So we have the gauge, and what gauge does, or what we could use gauge to do is for performance, it's like a performance indicator. So for the gauge, it's something along the lines of you have a target, and you've done, you've made money, or you've made some sales. So gauge will just help us to find that, okay, if the sales that we've done has met our target or has exceeded the target, or we're not even up to target with what we've done. So I'm going to enlarge this, and I'll click the gauge. Can we see my screen?
Yes.
Yes.
Okay, thank you. So I'll click the gauge, and then if you look here, you see the value. So let me use revenue as our value. So I'm going to drag revenue, and I'm going to drag revenue and drop it on value. Then okay, so we have that. So what we can do, because here we don't have the minimum value, we don't have the maximum value, and we don't have the target value, but what we can do is go to this format your visual, click it, and we can set our target. We can set our target. We can set our target. We can set our minimum value, and we can, well, get maximum value as well. So just give me a moment.
Hi, Noye. What are we? Which of the data?
I'm sorry, what did you say?
I said, which of the data set are we using? Drop two of the.
Using the one that we use in cookie, what's the name called? Cookie company.
Can you drop it? I saw adventure work sales. Can you
No,
drop
that's
it
for
again?
the next. Okay, I will.
Thank
I'll
you.
find it. Claudia, have you seen it?
Yes, I've seen it. Thank you very much. So what are we
Okay.
doing?
So we are trying other visualizations, but we're using this data set. So at the moment, I'm just trying to get us to understand some of the KPI visualizations. So there's one that is called the gauge, which is what we're using right now. So essentially the gauge helps you to like keep track of your progress, and excuse me, the gauge helps you to keep track of your progress. And with using gauge, you can set your targets, you can set your minimum and your maximum using gauge like we have here. So here we have like our revenue is we're using our revenue in this case. So it's possible like we have set our own target for our revenue, right? And so what we want to do is see how to set the time, put the target here, and see if our revenue has exceeded the target, and if the revenue has not exceeded our target. So for here, we can see that our target at the moment is, or we don't have a target rather. So we can see that the total revenue is 4.699 million. So we could just set like a target of we could just set our minimum. So like let's just say maybe 3.5. Oh, this is not the, sorry. I don't know, I seem to have lost where to enter my values. Sorry, please, I'm going to come back to this. So that's what gauge does essentially. So we just use that to set our target and see if we've gotten our target, or if we have exceeded, or if we've not even met the target. Same thing goes for the KPI chart as well. So the KPI chart also does, the KPI indicator also does the same thing as the gauge. So that's for like those kind of visualizations. Then if you want, there are like other fun visualizations too that you can find on the Power BI platform. So if you want to view that, you could either click here and click get more visuals, or you could go up and click more visuals, and you click from app source, and would see a couple more of other visualization fun ones that we could use. So I have clicked the app source, and it's just taking a while to open. And you could do this too while you're on your system. Maybe yours would open faster than mine. So these are other visuals too on Power BI. More creative ones, more interactive ones, more
Are they free?
Yeah, they are. They are free. So these are more interactive ones, more fun ones that you could use. Let's see, we could try one. there is particularly one that I like. Let me see if we can get that one.
Sorry, please, where
Sorry,
did you
please,
go?
how did you get here?
I didn't
Oh,
really-
Good afternoon.
Good afternoon. So let me close this and then take us back. So from on your Power BI on your screen, like this, up where you have your visualizations on the right, yeah, that should be the right. Where you have a visualization on the right, just come to the bottom. You'll see 3 dotted lines on a straight line, vertical, so or horizontal rather. So click it, and you would see get more visuals. You'll see all these options, right? So if we click get more visuals, something should pop up on your screen. But can you see my screen? This is what comes up on your screen. So these are more visuals that you can use on Power BI.
It's asking me for my email address.
Oh, you are not signed in?
Oh, okay.
Same here.
Oh, okay. So I guess maybe you can only access it if you are signed in. Is any other person having the same issue?
Me, but
Yeah,
it asks for my password too.
Me too.
So if your password is auto-saved, it will not require password. Just go like that.
Yeah, so the thing is, I'm guessing if you're not signed in and you can't access it, it means that you might have to sign in to access it. You have to sign into Power BI Desktop to access it. So that's something that we can try doing maybe at the end of the session today. Try and sign in. Like I used my LBS mail to sign in, and I think that's a better choice. Or any organization's mail, just personal doesn't really. Not sure that personal would work so much though, but yeah. So just sign in, and if you can
Personal did not work, so I guess
Yes.
it's official or school.
yeah, exactly. Yes. So if you can sign in, you can access this as well. But pending when you sign in, let's just do something 1 or 2 with this interactive visual. So
That means
I
we
was
just
saying-
reviewing.
yeah, you can just look at my screen. It's not the major thing we have to do today, but this is just me trying to open our minds to like other kinds of visuals that you have here on Power BI, other than the ones that you have on the screen out there. So these are other ones that you can find. There are a lot. Just for us to get ourselves familiar with it. So there's one that I think this should be it. There's one that I like a lot. Yeah, it should be this one. So this is an animated bar chart. So it just shows changes over time, and it is loading. So all you need to do once you open the visual the views that you want, you can just click on add, and it will add it. Where you would find it will now be at the bottom of this visualization. This is it here. It says the visual was successfully imported into this report. Yeah. So where you find it is just at the bottom. This is it right here, animated bar chart trace. So I'm going to delete this gauge because we're going to come back to it. I'm not really going to let it slide like that. So we're going to now use this animated bar chart race. So I'm going to click it. And there are a couple of things that you need to fill in here, right? So the value, I'm going to still use revenue as my value. The period, I'm going to use, I'll probably use the year as my period, right? And I'm going to use product as the name. So you see, it just starts to wasn't what do I call it? Okay, let me remove year and put month instead. So I'm going to put months here. So you see that it just starts to, move according to the numbers to get it to the particular number that the Excel or the file has. So we can see that over the months, we made this amount of money selling chocolate chip for the 2 years, or for both 2018 and 2019. We made this amount selling chocolate chips. We made this amount selling white macadamia nuts, and the list goes on. So there are even others that you can try. We could try using let's see. Let's get more visuals. This will probably be the last one that we'll try before we go into today. So we could try using this fish one. So it loads. The next thing is just add it. Once you add it, you'll find it under your visualizations where you just click it. But note that it doesn't permanently stay here. Once you're done, if you open a new work, a new file, if you open a new page or a new file, you won't find it. So you still have to go back and add it, unlike these ones that are permanently, installed here. So let's try the fish, the Enlighten Aquarium, and then we're still going to use revenue and products as well. So we're going to have the fish, and we're going to drag the revenue to the fish size. So let me enlarge this. So we see that the bigger the fish, the bigger the revenue, and the smaller when the fish is small, it means that the revenue was not as much, right? So we see for fortune cookie, the revenue was 454,000, but you see this one now, the chocolate chip one, the revenue is 1.69 million. So the bigger the value, the bigger the fish, but the value is small, the fish is also small. And so we can play around with these sort of visualizations as well. Okay, so I'm going to just wrap up with this, and then we'll go into data modeling and its structure. So data modeling is also known as like the tabular model, and this is because the structure of data modeling, or the structure, is made up of one or more tables. So, and the way that we can add tables to our model is to gather data, is to add our data like the way we always do. We get data from our sources and we add our data and everything. So that's one way of adding data to your model. But there's also another way of adding data to our model, and it's by writing a DAX formula and everything. But we're not going to go into DAX. Yeah. DAX is more above my pay grade though, but you get what I'm saying. So the DAX is like a whole language entirely that needs to be written. It's a functional language that needs to be written on its own. So there are different types of data modeling, but for the purpose of our Power BI and the stage that we're in now, we're just going to look at the dimensional type of data modeling, and it's the most extensively used data kind. It's the most extensively used type, and under it we have like the star schema design. So the star schema design is also known as the dimensional data modeling, and it's the best model for Power BI desktop. Now it's user friendly, and the structure, the design is classified in facts and dimensions, right? So let me quickly display. Let me show the screen. So while that is coming up, so yeah, so we have for the star schema design, we have the facts, we also have the dimension. We have the facts table, we have the dimension tables. Now, the facts table is usually at the center of the model. So it's like, it's in the middle and it has branches. So you know how the way the shape of a star looks like, you know, with like 5 points and all that. So yeah, that's what it looks like. So it's in the middle, and then you now have other tables that are connected to it, one around it. It could be more than 5, but like just that structure of having one around it, connected to it. That's what makes it the star schema design. So the facts table is the center, and it's like it has more rows, it has more data in it, and then you have the dimension table, which is like, you know, around the facts table, and it has less frequently changing data, in the sense that it is just, it could just be like, you know, like we did in SQL. You could have product, you could have shippers. So those are like those distinct data. Those ones that are not numerous, are not multiplying, they're not one detail of it is not more. It's just distinct. They're just unique, right? So that's what like the dimension table. That's what the dimension table is like. If I may, let me share this so that we can see. Yeah, show this. So like what we're looking at here, this one in the middle, the one that has others one, is the facts table, and the ones around it, the ones surrounding it, is what we just call the dimensions table. So you have and you know, they all have their links to the facts table. Now those links those links are what we call cardinality, and there are different types of cardinality. So from my PowerPoint that I just shared before, there are four types of cardinality, and you have many to one. So this many to one, it's like a reverse. It's the reverse of one to many. Yeah, this will be one to many. So it's a reverse of one to many. So you have like your facts table, which is your customer table from the diagram here. You have your facts table, and then you have different offsprings, like you have different tables that are connected to your facts table one way or the other. So in your facts table, you have your order ID, you have your product, you have your delivery address, and these other tables are also a standalone by themselves. So how do they connect to your facts table? So they use that, you know, unique identifier, or that their primary key to connect to your customer table, and that will probably be the order ID. For order, it could be the order ID. Under your customer table, you would also have order ID. So that's how they can make a connection. That's how you can see a relationship between that customer table and your order table. Same goes for product. It could be product ID, and that's how you can state the relationship between your customer table and your product table. Or it could even be the delivery address. So essentially, there must be one column in these tables that is also in your customer table that will connect them together. And let's not forget that in your customer table, those things can appear multiple times. Like you can have maybe a customer with order ID with customer with the order ID 1, it can appear multiple times on your customer table. Maybe the customer made multiple orders under the ID, but in your order table, you would just see it as 1, right? That's why I said the fact table, it changes, it has many forms, it takes multiple forms, but the order ID just picks what is distinct. You can even say like maybe it just picks that one thing. So you can have plenty ones in or plenty twos in customer table, or in your order table, you just have that 1 or that 1 2. Same thing goes for the product, and same thing goes for the delivery address. And we would see that in an example that will follow shortly. So this is one-to-many, and the reverse is many-to-one. Then you have one-to-one. So this is one-to-one. In this diagram, you have the employee table and you have the address table. Now, the employee table has so the employee table has different columns. You have the EID, which could stand for employee ID. Then you have first name, last name. And the address table has the address ID and also has the EID. So what connects them together, or what's the relationship between these two tables? It's the EID, right? So when it's one-to-one, it's such that exactly what you have in your EID on your employee table is the same thing as what you have in your address table. So take, for example, your employee table has only 5 employees, and those 5 employees are what, their IDs are what is exactly in this employee table. Now, first, let's go to the address table. In your address table, you also have your employee ID. If it's exactly the same thing, that's what you call one-to-one. So it's exactly 5. The number is 5. It doesn't exceed 5. One employee ID is not duplicated. It's just one employee ID, and it's all 5 of them there. So that's what you call one-to-one. And generally, we advise that you just fuse it together rather than have it, separate like this. You just make employee table all together in one. Fuse these two tables rather together. So in your employee, you can now have employee ID, you can have address ID, you can have first name, and you can have last name, rather than separate them, because what is unique about the two of them is actually the same in both of them. Are we following so far?
Yes, Maya.
Yes, Naya.
So then there's another, then there's the last one, which is many-to-many. Many-to-many is, I'll just say it's quite complicated. And an example of how would we explain many-to-many? Here we have, on our left, we have the order ID, we have the product ID, we have delivery address. On the right, you have the product model, you have feedback. Now, let's take the first one, the order ID and the product model, which is product model ID. So under the order ID, there are many IDs under the product ID, so to speak. So one ID can have multiple product models that were ordered. And it's not just one ID that is on that, not just one ID that is in that order. You have multiple order IDs. And one order ID can even appear more than once, right? So you have multiple order ID and you have product model ID, where one ID from the order ID is placing many product model. So that's many to many. So I can have take for example, I can have order ID 1, and in that order ID 1, I have maybe product model ID ranging from 1 to 5, right? And even with my product model ID, if I'm connecting it back to my order ID, I could have one product model ID and it will have different order IDs attached to it as well. Is there some confusion? Can we hear me?
Yes, Naya, we can hear you. What I am trying to visualize is, well, what you're trying to say here in this many-to-many relationship is that, so you can have order numbers for, let's say, from customers attached to customers, and then you have different product models. Let me just, for instance, use a car. So you have a Toyota Yaris, you have a Toyota Venza, you have different models of that. So you can have multiple IDs that would attach to different product models because the orders are coming from different customers ordering for the same product model. And then you can also have, and I mean, you have different ID numbers attached to different product model, which means invariably you have different products in different ID numbers. So you can have ID number 100, ID number 200, 300, and then for each of those ID numbers, you have a mixture, a different mix of product models for each of the others. I think that's what you are trying to say, right?
Yes.
Okay.
So is any other person confused? Can I go on?
I'm not clear yet. I don't know. Let me try to understand. Like, is it that you have Toyota Corolla, Toyota Camry, but they are all like Toyota? Is that what you're trying to see? Like, they have different IDs, but they are similar products.
Okay, so let me see if I can put it this way. Let me give a different example. And take for example, you have different subjects, and you have different students, right? You have you have different subjects and you have different students, and you know that each student takes some particular subjects. So I'm going to say that the many-to-many relationship here will be the various number of subjects and the number of students that are taking that subject. So essentially, you see that one student, if you take one student from one line, you take one student from one table and connect it to the subject, you would see how many the student is offering, right? And if you take one subject from the other line and connect it to the student, you will see how many students are offering that subject. Is that a better explanation?
Okay, it's getting clearer. Getting clearer, yeah.
Yeah, so that's what the many-to-many feels like. That's what the many-to-many is. So that's for students. Let me see. I could use an a workplace, right? So you could find an employee and you would see a department. So let's put our employee on the left and the department on the right table. So you have employees that work in different departments, and you have employees that work in just one department. They do several works in just one department. So from the left table now, connecting the employee to the department, you could see one employee in several departments, which is on your right? And then connecting the department to the employee, you could see one department and you would see several employees working in that department. Do you understand?
Yes, yes,
So this is clearer.
yes, yes.
So that's what the many-to-many cardinality feels like. So depending on what your model is like, you will just see this sort of connection. Your model, yeah. How do I put it? So your model would show you, yeah, what kind of connections have been created between all these all the tables. Yeah, so it's not just star schema design that we have when it comes to dimensional modeling. We also have the snowflake, but the snowflake is quite, intensive, so to speak. For the purpose of now, we're just looking at what the star design looks like. So another thing about Power BI is that these connections that we are actually trying to understand, it can make these connections automatically. So this is all for the cardinality. Let's quickly look at a Power BI. So Power BI can automatically create these connections. So if you look at, if you are looking at my screen, so I click file, if I go to options, I click options, it's coming up. So if you scroll down, you go to data load, you click data load, you would see under relationships here, you would see import relationship from data source on first load, okay? And you also see auto detect new relationship after data is loaded. So it automatically detects new relationship for you. And if you want, you can uncheck it and manually create the relationship yourself. And at times, Power BI might not give you the correct relationship. It might not be the correct thing that it's linking up. So you can always delete that connection it has made and reconnect it. So I guess we can just go into it and see a couple of things. Do you have any questions at this point? So I'm leaving mine checked, but you can always uncheck it. So guess I'll have to open a new sheet. From the data from what I sent to the group, the one in the zip file, we can extract it. If we have extracted it, then we can now start. Then we can now start placing it in our Power BI, and then we would see the kind of relationship that is being created. So I'm actually trying to delete this one. Have we extracted the data? Have we downloaded it? Have we extracted it? I think that we can still do this together. So let me see what screen you're looking at. Okay. All right, so I'm going to import data from my Excel workbook and so I'm starting with orders. So for the purpose of just looking at what data modeling is, I'm just going to load it straight. I'm just going to go on and load the data and without transforming it.
Which file is this one, so please? The one you uploaded?
Okay, so yeah, it's the one it's in the zip file.
Is it a Northwind?
Yes.
All right.
Is it a Power BI file or Excel file?
It's Excel. So I just loaded this data and I came down to the model view, and this is it here. Right, so I'm still going to go back to that Northwind file that I sent, and I'm going to bring in other details. Again, for the purpose of this, I'm just going to go straight and load it. So because mine is already like automatic to create relationship, right? So Power BI has already auto-detected the relationship and has made the connection for me. But I'll still go in and I still have about 2 more, yeah. So I'm going to bring in my shippers. Just to make it a little more organized. So this is my shippers. I'm just dragging for space so that it is obvious. Then I still have one. I think the last, I'm going to bring in the last one now. So if we have done that, we would see something of this sort on your screen. So it you can see that Power BI has automatically detected the relationship and has made the relationship, has created the relationship as well. So if we just put your mouse, just hover over this connection line or this line, you would see the two things that were connected, the two things that were similar in both tables that created the relationship between both tables, and it was the employee ID. So with the employee
Chinonye,
ID, yes.
I brought in my data, but I don't know how you got to this platform where you see the connections.
Okay, so can you see my mouse moving on the
Yes,
left?
I can see.
Yes, so the third
Okay, the
one,
last
model
one.
view.
Excellent.
Yes.
Okay.
Sorry, can you do the mouse again? I didn't see where you clicked.
Okay, so this is me here. Report view,
Okay, so,
data view, the third one, model view.
okay.
So are we on the same page now?
Yes.
Okay, so this is if I had other tables too to join, we would probably have like tails as well. We'll probably have like maybe one or two more at the bottom, but this is still good considering. So this is a classic example of a very simple example of what the star design looks like. So we see the facts that I was talking about in the beginning. Our fact table is the one in the middle, the one with others one, the table named others one. So that's our fact table. And we see the other ones joined to it. The other ones around it, it points. And those ones, we'll call them the dimension table. So this is because the data in these ones are not even changing. They're less, they change less frequently. So, but the one in the middle is where, if a customer places an order, it comes straight to the one in the middle, and you can see things like the customer ID. You still have to find a shipper for the customer. The other detail of the customer, the product ID of the product that the customer wanted. Everything is literally in this fact table. But then if you look around the table, you'll see shipper. Shipper is just literally the shipper, the name of the company and the ID of the company. Then you have the employees, probably the employees are connected to the customers. So you just only have the details of the employees in that table. Then the one by the side just talks about the product being ordered, the quantity or the price of the product, and discount if there is one. But you see the one in the middle talks about everybody, talks about the customer, talks about the employee, talks about the shipper, the shipping company, the amount that you're going to pay for shipping, and the list goes on. So that's why it's the fact table. There's plenty data in it and it changes a lot. So if a customer places an order right now, this the one in the middle, that's the orders, the fact table will be affected, while others remain constant. This one would change because a customer has placed an order, right? So yeah, that's a classic example of what we were discussing. And when we look at these arrows, right, you would see once your mouse hovers over that connecting line or the connection line, you would see that the two columns that are connected will just be highlighted, and you see that they are connected based on their order ID. For this one, the connection between orders and order details is the order ID. So we see the connection that is made there. So when we talk one to many, this is what it looks like. So this star is many, and this one is one, but we need to edit this connection, right? Because where the many is from, is on the orders, not order details. So order doesn't have it's not a frequently changing data, right? So the orders is where there's plenty that we duplicate product ID in the orders, which is the one in the middle, this one. So we can't and it's connected based on order ID. So the one that has duplicate order ID is not okay, let me close this so that I'm not moving everywhere. So the one that could have plenty order IDs, is in multiples, is the orders one, which is our fact table, not order details. So what we can do, we can change the angle of that connection. Instead of having it as one to many, instead of having it as one here to many here, we're going to make it many to one, or one here to many, which is the orders. So basically we double click it, and so we're going to call the cardinality one to many. We're going to, what's this here? We're going to switch it from orders one to order details. We're going to say, okay. So I was thinking that this is supposed to change. So if it doesn't change, well, I guess it just means that reverse is the case for this one. So it's only appearing uniquely in orders, which is the fact sheet, or is appearing multiple times in order details, which is a dimension sheet, which is a dimension table, and is appearing multiple times. So we probably have multiple order IDs in the order details, but we only have it uniquely appearing one without duplicates in the orders one. So if, like I said, I mentioned manually creating the relationship in a data model. So this one was already automatically created, but we can delete one and test and look at how we can create the relationship in this data model. So, okay, so, wow. Okay, So we have this table and we have this facts table. To create the relationship, we have to find what connects them, what, connects the two of them. So when we look through the columns in this table, and we look through the columns in this other table, what do we see that is, what can we find in this and we can find in the other one, right? Be it multiple or not. What can we find in this and what can we find in the other one? So, sorry?
No, you said what can we find in this and in both is other ID.
Yeah, so other ID. So what we can do, to create that connection, all these lines and all, what we can do to fix it in there is to drag. So we're going to drag the other ID from here, or drag the other ID from here, and one should bring it close to the other ID here. I mean, you are seeing the whole shape and everything, it changes form and all, and just drop it. So when you do that, that's you manually creating the relationship between two of them. So when you do that, it just, it comes up and everything. So yeah, that's how to create the relationship by yourself. Then let me see. Yeah, so that's what I have for data modeling, because we're looking at something really simple. So for the one-to-one, it is advised that you just merge the tables, like merge the tables together, maybe on your Excel spreadsheet, have the tables together, because the unique identifier in both of them are literally the same thing. Then I explain the part for the many-to-many, and then you have the many-to-one or the one-to-many. They're reverse of each other. Many-to-one is the reverse of one-to-many. Right. So those are like the 4 cardinalities that each data model is defined by. Let me quickly share my screen. Share a different screen this time around. So this is the one for the second Excel spreadsheet that I sent to the group, the adventure works. So this is what the data model in this one looks like. Now we can see that they're like in this one. Let me zoom in. In this one, you're seeing about 3 different connections made here. Now, if we hover over every connection, you will see what connects the 2 of them. So the order date key here and the date key here, they are what connects these 2 tables together. Then if you hover this one, you would also see due date and date key are connected. And if you hover this one, the date key is actually connected to below. Yeah, it's connected to the ship date key. Now, if you notice, this one seems to be like a straight line, but this one, the line is dashed, right? So for this one, the one that the line is dashed, is inactive, right? Meaning that yes, there's a connection, but we're not we're not there. We're not working based on that connection. Connection that we're going to work. The connection that we're going to work on, or the connection that we're working with, is this first one that the lines are not dashed, the line is straight and everything. So this one here, the one under once you create like a what do you call it? A relationship, right? If it's dashed, it's inactive, or if it's a straight line one, it's active. And I think this is just like a beautiful description of the star schema that we were talking about. So this one even has like, this one has 6 points connected to the facts sheet, to the fact table. So this one has 6 points connected to the fact table. And if you see the one for the snowflakes, the snowflake design would have children and grandchildren, so to speak. So from this fact table, going to the dimension, you will see the dimension tables will also have other tables connected to it. They will all have other tables connected to it. It's almost like they're building a family tree, so to speak. So that's like, that's more complicated and that's more intricate than this, than this what do you call it, than this star design. So yeah, I can say that these this is on data modeling. And if you want to know more about data modeling and anything concerning Power BI, if you want more knowledge about it, and want to read more about it, we have a YouTube channel. So you could always visit our YouTube channel and you would see previous lectures, previous sessions that have been treated on Power BI. And you would also see this one. By next week, you should be able to see this one, so you can go back to it as well. And I'll put up our channel link, our YouTube channel link on the group chat. And then for more info, you could also go through Power BI on YouTube as well. And also, I don't know if I'm allowed to do this, but there is also another person, there's also another channel that you could check out concerning Power BI, all things Power BI. It's Guy in a Cube. You could also check that one out as well. So like, there's more intricate, there's more detailed knowledge of Microsoft, of Power BI in those things. So I have to.
Sorry, please. I didn't get the last thing you said. You said Guy in a Cube or what?
Guy in a Cube, like Guy, GUI.
Okay.
Yes, Guy in a Cube. So, but also we have our YouTube channel so that you can also look at, and we have historical data on Power BI that you could watch and get more out of Power BI than, we only have like 2 hours and we can't really do everything. So watching these channels can even help you broaden your horizon and broaden your knowledge on what Power BI is. So I think that's all that I'm going to do about data modeling today. And do you have any questions? Do you have anything that we need clarity on?
So I guess maybe just to clarify, I'm not sure I got maybe you mentioned it, but I didn't really get it. So analyzing the relationship between these different tables or fields, will I say, what's in trying to do a data model, right? I'm trying to understand what we aim to achieve by analyzing these relationships.
Okay, so analyzing can you hear me?
Yes, I can hear you.
Okay, so when we're doing for the data modeling, right, it's connecting different sources of data
Mhm,
together,
mhm.
right? So you could have one table that has all things sales. I'm sorry, did you join us in the SQL sessions?
I joined, but I wasn't consistent, to be honest.
Okay, there's no
Oh.
problem. I just needed to know how to explain it to you. So
I think what I'm trying
connecting,
to understand is the output. So what's the output at the end of the day? I think-
yes. So when you're able to connect, from different sources, whatever data it is that you need to use for your visualization, you just go straight to your visualization tab and you create reports. You create reports from your data model.
Okay, so Power BI is also able to give us reports connecting this whole data from the whole a combination of the files we've
Different
uploaded.
tables. Yes. So if you look here, you see something about it looks like an eye that has been closed or something.
Yes.
Okay. Yeah. So those things literally are just hiding what you do not need when you want to build your visualization,
Okay.
right? When you have created this data model, when you have been able to connect all the things that you need to be connected so that you can go on to visualize your data. If you find the one that you feel like you do not need it in creating your dashboards and your reports and all that, you could just click on it and it will just hide it. You wouldn't find it there, right? So this one just helps you to merge various, from my own understanding, this helps you to merge various tables, right? That has different things that you need to create your visualization. If you can't find all of it in one table, right? So it helps you to bring all those other ones together, and then you piece them together, and you go on to create your dashboard, you create your report, and all of that for your business or for your workplace or for your organization.
Oh,
I
okay.
don't know
Maybe
if I
we can
can.
create a dashboard now. We can do
I-
maybe something
I
from
want-
this.
I
So,
want to ask if I can make additional contribution to answering this question.
Absolutely, yes, sir.
Okay, this database modeling is I think what we are trying to do here is try to explain database architecture or database design. And there is a common terminology we use in database design called nominalization. It has its own benefits. I think it is one of the things Dr. Francis shared with us one time, or maybe he taught us. Data normalization, not nominalization, normalization. It has its own benefits. It makes it easy for you to have, if you have a data to work with, you can connect it with another set of data to get in additional information. For example, if you have the database for these guys, both INEC or the voters register, and you want to call, you have somebody asks you to analyze it, do some additional work by looking at the database of Nigerian Population Commission. You want to do a kind of connection. What can you use to extract? Maybe the database for INEC actually shows some details. You now want to do some validations. So you want to check if so people living in a particular region actually corresponds with the same data that Nigeria Population Commission is reporting. So you just use maybe BVN, a unique ID, maybe BVN or NIN, or a particular ID that is common to both of them. That is, you have one table containing INEX database, and you have Nigeria Population database. Once you just have the two of them, put it on something like SQL or Power BI as the case is, like this, you can connect it. It's just similar to something we did in Excel when we're using VLOOKUP. Something like VLOOKUP index match. That is what this matching, this link, what do you call this connection? That is what this connection is doing automatically for us. It makes life easy. Then it also has its own benefits. Instead for you, you don't need the entire data of everybody in Nigeria. Since it is only the people that register that you need. So in that kind of situation, you can keep the data of people who registered on one sheet, then the other information on the Nigeria Population Commission, maybe things like religion, all this additional information that may not be necessary, religion, vocation, tribe, and things may be captured in NPC's report. So if somehow you need those information, the fact that you are working with only this Nigeria INEC database, you can go and extract relevant one without unnecessarily adding those columns to your INEC database, which will make your file heavier and slow to retrieve information from. So those are some of the benefits of database modeling like this. So you just use it to connect. Bringing it down to a banking sector where maybe some of us may be working or maybe we may be conversant with, you have a record of all the customers in the bank. They now have a record of all the transactions in a different database, even different databases, or according to dates. Maybe today's record will be captured somewhere and so yes, different dates. So there is a way they connect all this data. Otherwise, you can imagine if all the data for 1 year for GTB example is inside one file, it will be a disaster. So that is the essence of this modeling, what we are using it for. So you have the sales data for a company, a shop. Then you have the customer data. Well, nowadays, when you go to a particular shop, they ask for your loyalty card or they ask for your details. That thing is exactly what we are doing here. It has the way for they can use it to track each person, know the needs of them, and be able to get some people know how to plan their promos and things like that. So I think it would be good if we can have a hands-on data set to work on. It will really help us to really understand this thing better, and we'll be able to appreciate what Chinonye is revealing to us. It looks like theory now, but I think Chinonye should give us practical and let us play around with.
Yeah,
Yes,
thanks,
absolutely.
Ayobami, I agree. And maybe just one more question, maybe before Chinonye, if she is able to give us a practical.
Okay.
Are there instances whereby, for some reasons, you can't, let's say we gather data from different sources, we can't seem to find a relationship? Does that happen in practice? And if so, how do we deal with that? Does it mean that you then have to then consolidate the information? But no, you can't even consolidate without a relationship, because even when you consolidate, there should be a reference. Yeah. So I'm just wondering, in practice, does that ever happen? And if so, how do you deal with it?
There are instances like that. In such occasion, definitely you need a relationship. So in such instances, you try to create relationships. There are some that may not be readily available. And it is also good to understand we are working, learning all these things, they call it data analytics and stuff like that. There are some elementary things, maybe algorithm, data structures, some of those things, variables. Then there's this thing they call this a unique ID referencing. For any data we want to collect, try and create a unique ID for it. Somehow it is important. So there are ways where with the instances when you don't see a corresponding related references. So you create them. Example, if you have, how do I put it? Name, surname, and all those other details, biodata details on one side. And on the other side, you don't have those things. You may have maybe something like account number of a particular person. How do I? I'm thinking of how to a real life situation. Okay, let me just give you a simple one. I will think of another one that is really practical. A simple one is maybe on one side you have name, email address in one database. Like when you click on some site, it just say put in your name and email address. That is all. And such a person happens to now see a record of all people, all contacts, maybe a telephone number of everybody in a particular database. How would he match name, maybe first name only, or first name and surname separately, then email address? And you now have another place where you see first name and surname together in one cell and other telephone number in another, and you want to connect the two of them. So you have to do some adjustments. Yeah, you have to be very careful about it. Here you have name, surname. So you do concatenation, name and surname, you concatenate it. Then the other side, and you know that when you are concatenating, you have to put space in between. The other side, you have name and surname already together. And then you will be able to do a kind of match, provided that you are lucky those things are unique. That is why in any data set, they always have a unique ID. You have the customer ID, most of any database they are collecting anywhere. You have other ID, you have shipper ID, you have different ID for every database that is being collected. But if you want to deal with raw data that is not structured, not arranged, not collected properly, then you need to do something they call data cleaning and do that adjustment. Concatenate name, surname, or even if you look at the email address, you may now try to split it. If it's like some organizations, the way their email address is structured is first name dot surname, you know, that kind of thing. So you rearrange it, you now walk around that thing, and you'll be able to do the match. If you're able to get a match up to a certain percentage, you may feel comfortable, and you'll be able to use it to do your analysis. I did one, there was one data set I played with hackathon that some people did. I just got the data I worked with. They gave me United Nations figure for something. They gave me another data set for some poverty level in some places and health in some different places. I had to work on, I had to do data cleaning, remove some things, and it was a really interesting one. It took me time, but it was challenging. And that is one of the kind of instances you may have. So after then, you're able to establish the relationship.
Okay, thanks, Ayobami. Clear. I
All
appreciate
right.
All right, thank you very much, sir. So, yeah, I guess that's about it for data modeling today. And about the data sets, definitely, I'm going to send something up so that we can test the waters, I guess, so that we can familiarize ourselves with the concept of data modeling. And that's about it. Do we have any more underlying questions? Anything that's bothering us concerning Power BI so far?
No. No,
Alright,
yeah.
so, okay, yeah, I can hear you now. So I wasn't hearing any other person. So I think I'll take the silence as a no too. So we've addressed the issue for today. So yes, I'll see us all next week, Sunday again, same time. And I'll drop the link to the DA Club YouTube channel so that we can also visit our YouTube channel. Thank you everyone for joining in today.
Yes, Noye, before you go, please. The YouTube channel, can we also have the link on the WhatsApp profile, the same way we have the sign on, the Zoom link there?
Okay, so I'm going to try and see if it will fit. It might not fit.
Okay, so
Yes, sir.
thank you.
All right. Thank you so much, guys, for joining. Thank you. Have a great week.
You too. Thank you.